Okay, let's go through the study guide for Unit 3, Quiz 1. So we were talking about polynomials and how to write equations when given graphs and how to identify different aspects of a polynomial function given an equation. So let's break it down a little bit. So when we're talking about a polynomial equation, and we're trying to write an equation here, the first thing we want to look at is where the zeros of the polynomial are. So the zeros are the x-intercepts. And then we're going to look at what's happening at those zeros. So I'm going to start by writing f of x equals a. We don't know what a is yet. We actually have to find a. And then I'm going to have all of my factors here that are going to be given by the zeros that I have. So actually, let me write this lower. I just don't have enough space. So let's do this. So I have f of x equals a times x plus 3 because I have an x-intercept at -3. So -3 would make this factor 0. So that's why I write x plus 3. Then I have another 0 at -1, so I'm going to write x plus 1. Then I have another 0 at 2, so I'm going to write -2, x minus 2. And then I have another 0 at 4, so I'm going to write x minus 4. So I'm looking for the behavior of the graph. So I'm looking at the 0, and I'm like, okay, a line goes straight through, so that means it's just to the first power. So this factor is to the first power. This line goes straight through, first power. This line bounces off, so it's actually going to be squared. And this line through 4 goes straight through, so it's to the first power. So now I have this polynomial written in factored form, right? It's written out as a series or a set of factors. The only thing we don't know is a. So the way that we find a is by choosing another point on our graph and substituting the coordinates in for f of x and x. So in this case, the other point that we have is right here. Sometimes it's somewhere else on the graph, but for us in these two problems, it's going to be on the y-axis. It's our y-intercept. So on our y-intercept, the coordinates are 0, 3. So that means that f of x, or y, is 3, and x is 0. So I'm going to do a times 0 plus 3 times 0 plus 1 times 0 minus 2 squared times 0 minus 4. So if I simplify this, multiply all of these things together, I have 3 times 1 times -2 squared is 4 times -4. So now I have 16 times 3. And so that is going to be, oh, it's -16 times 3, which is -48. So I have 3 equals a times -48. So to find a, I just divide by -48 on both sides. Oops. All right. So now I know a equals 3 over -48, or -1/16. So when I'm writing my function out, I'm going to say f of x equals -1/16 x plus 3 times x plus 1 times x minus 2 squared times x minus 4. That is my full equation. Runs into my other problem a little bit, but that's all right. We'll try and save space on this next one. So same idea here. I'm going to look for my x-intercepts. So I have 3 of them. So I'm going to have f of x equals a, and then I'm going to have 3 factors. So my first factor here is at my first x-intercept is at -2, so I'm going to write x plus 2. Then I'm going to do x plus 1, because it's at -1. And then I'm going to do x minus 4, and this comes down, slows down, then goes through that point, so it's actually cubed. So that's what a cubic function looks like. So if it's squared, it bounces off the x-axis. if it's to the first power, it just goes straight through. If it's cubic, it goes through the x-axis, but it slows down before it continues. So that makes it a cubic function. So now what we need to do is find one other point to use to replace f of x and x so that we can find a. So the other point that we have, again, is our y-axis. It's not always our y-intercept, but in this case, again, it is. So we have a point at 0, 4, so that means f of x is 4, x is 0, so we have 0 plus 2, 0 plus 1, 0 minus 4 cubed. So 4 equals a times 2 times 1 times 4 cubed, and 4 to the third power is, 4 times 4 is 16. 16 times 4, I believe, is 54. And it's going to be a negative 54 because negative 4 times negative 4 times negative 4 gives me negative 54. So I have 4 equals a times negative 128. There it is. Divide by negative 128. I'm sorry, it's 108. Wow. Right? Yeah. Let me double check this. So we got 4 to the third power. Oh, it's 64, that's why, not 54. That was silly. Okay, so negative 64, negative 128, perfect. And if I divide this by, or if I divide 4 by 4 and negative 128 by 4, it simplifies this fraction to negative 1 over 32. So when I'm writing this out, I have f of x equals negative 1 over 32 times x plus 2 times x plus 1 times x minus 4 to the third power. Okay, so let me rewrite that. A equals negative 1 over 32. All right, so that's how we write those based on a graph. The next one we're going to look at is polynomials finding intercepts, degree, and behavior. All right, so we are actually going to sketch these graphs as well. So when I'm looking for zeros in multiplicity, multiplicity is how many times that 0 shows up. So that's shown by the power on that factor. So x would need to be positive 1 to make this factor 0. And it has a multiplicity of 3 because it's to the third power. So I would say x equals 1, multiplicity of 3. And then for this one, I would need this, so negative 2 plus 2. So 2 times negative 1 would give me negative 2. Negative 2 plus 2 is 0. So I would need x equals negative 1 to make this factor 0. And because it's squared, it has a multiplicity of 2. If I'm looking for the degree, I'm looking at how many times x is being multiplied. So if x here is being multiplied 3 times because it's cubed, it's third degree, plus x is being multiplied 2 more times here, so this is going to be 2 more times. So all I'm really doing is adding the exponent of all of my x factors, okay? So this would be a 5th degree polynomial because it's third and second power. Leading coefficient, I'm going to multiply all of the numbers in front of x and make sure that if it's in parentheses with the power, I raise this number to a specific power. So I have negative 2 out front, and then there's only a 1 in front of this x, so it's just 1 to the third power, times 2 to the second power. So again, I'm looking at the number in front of x, the coefficient of x, and my leading coefficient out front, so the a value that we saw up here. So when I do this math, negative 2 times 1 times 4 is negative 8. So my leading coefficient is negative 8. So when I have a 5th degree polynomial with a leading coefficient of a negative number, my 5th degree polynomial see if you can see down here, is going to end in opposite directions, and it has 5 possible zeros, okay? But if it's a negative leading coefficient, so this is positive 5th, if it's a negative leading coefficient, it starts high and ends low. Okay, so it just flips direction. It's a reflection over the x-axis, so it flips over. Okay, so before we sketch a more accurate graph, let's find the vertical intercept. So this is where I substitute 0 in for x and figure out what f of 0 is. So -2 times 0 minus 1 cubed times 2 times 0 plus 2 squared. So this leaves me with -1 cubed is -1, so I have -2 times -1. This is 0 plus 2 squared, so 2 squared is 4. So this gives me a positive 8. Okay, so if I'm sketching this graph, I have zeros at 1 and -1. I have a y-intercept at positive 8. And I know that my graph is going to start high and end low. But I have to pay attention to what's happening at these zeros. So at +1, I'm going to have a point of inflection, just like I did in my top graph, or my top right graph in the problem before. And then for my x-intercept of 1, it's going to bounce off of the x-axis because it's squared. So I'm going to start up high and end down low, just like I said here. So start up high and down low, so it's going to go up, then it's going to go through, have a point of inflection, meaning it's going to slow down and go back through. Just like that, okay? So that's what my graph could look like. End behavior, so as x goes to the right toward infinity, f of x is going down toward negative infinity. As x goes toward negative infinity, f of x is increasing or going up toward infinity. All right, so for number 3, we're going to go through the similar process here. So my zeros are at -2, 2, and -1, because that would make these factors 0. I have at x equals -2. It has a multiplicity of, oh my gosh, forget the L, multiplicity of 2. At x equals 2, it's just a multiplicity of 1, so I don't have to worry about writing that. And then I have x equals -1, also has just multiplicity of 1. So I don't have to write that as well. The degree, so this is x squared, so x times x times x times x. So that's 4 times, this is a 4th degree. So if I have a 4th degree polynomial, it goes up and up at the ends. If my leading coefficient is negative, then it's going to flip over and go down. So leading coefficient is positive, I'm going to go up. Leading coefficient is negative, I'm going to go down. Okay? So leading coefficient, I'm going to take all of the coefficients of x and the number out front and multiply them all together. So this is 1 squared, so that's just 1. So 3 times 1 squared, which is 1. There's just a 1 in front of this x, so another 1, a 1 in front of this x, so it's another 1. So really my leading coefficient is positive 3. All right, and then my vertical intercept, I'm just going to replace the x's with zeros. So f of 0 equals 3 times 0 plus 2 squared times 0 minus 2 times 0 plus 1. Okay, so I'm going to do 3 times 2 squared is 4 times -2 times 1. So I've got -8 times 3, which is -24. Cool. All right, let's sketch this. So if I'm sketching this graph, I have zeros at -2, -1, and +2. Yeah, let's go here. 1 and 2. Get rid of this guy. Okay, super. All right, and we'll say we have -24 here. Again, this is just a sketch. We're not worried too much about scale and accuracy. We just want to know where it crosses the x and y axis. Okay, so it ends up and up because it's a positive leading coefficient and it's 4th degree. Okay, so up and up is going to be the ends. And then it looks like at -2, it's squared, it's multiplicity of 2, so it's going to bounce off. So it's going to go up. Then it goes through -1. So basically just going to do this. Go down through -24. And then it's going to go back up through 2. That's what our graph will probably look like. So as x approaches infinity to the right, f of x is going up. As x approaches -infinity to the left, f of x is going up again. So my end behavior is infinity and infinity. All right, the last couple questions here are polynomial division. So in this case, we can use any strategy. I'll post my answer key with all strategies shown. But I'm going to use long division for one, synthetic division for the other. And then I'm going to use synthetic division on the second side over here. Okay, so let's start out by doing long division on the first one. So when I set this up, I have x minus 4 on the outside, 5x cubed plus 3x squared plus 0x plus 1. Super important to add that missing degree of x, because it should always go from highest power all the way down to like our constant. So it should go third, second, first, 1. Okay. So let's go. Let's do the division here. When I'm dividing using long division, I'm just looking at the first term and I'm trying to think, okay, what do I have to multiply x by to get 5x cubed? So in this case, it would be 5x squared. So that'd be 5x cubed, and then 5x squared times -4 is -20x squared. And then I'm going to subtract. So the 5x cubes cancel out. And so I have 3 minus -20x squared. So this is 23x squared because that becomes addition. I'm going to bring down 0x. So now I have to figure out x times what gives me 23x squared. Well, if I add 23x, 23x times x is 23x squared. 23 times -4 is negative, oh gosh, is it 92? So let's go clear that. 23 times 4, so -92. X, I'm going to subtract. So this becomes positive 92x. Bring down the 1. So x times what is 92x? Well, x times 92. So this gives me 92x. And then 92 times -4, calculate, is negative 368. Subtract. 92x's cancel out. And then I get addition here, so 369. So this is my remainder. So my solution is 5x squared plus 23x plus 92 plus a remainder of 369 over x minus 4. So we write our divisor as the denominator of our remainder. Okay, so for the next one, we'll do synthetic division. So in this one, we're finding the 0 of the divisor. So I'm going to start with -5 on the outside. Then I'm going to write the coefficient of each of these terms, and it looks like it goes to the 4th power, then 2nd power. So I need to add 0x to the 3rd power in here. So when I write this out, I'm going to say 4, 0, 3, 2, -4. And then I'm going to go through my process of synthetic division. So I'm going to bring down the 4. -5 times 4 is -20. I add, so it's -20. -5 times -20 is 100, positive 100. 100 plus 3 is 103. Then I have 103 times -5 is -515. -515 plus 2 is -513. Those are big old numbers. All right. And then negative 513 times negative 5 is positive 2,565. And this end piece is my remainder. So I'm going to do negative 4 plus 200 or 2,565. So that gives me 2,561. So I'm going to now write my solution with one less power than it started with. So this is 4x cubed minus 20x squared plus 103x minus 513 plus 2,561 over my original divisor, which is x plus 5. Okay, so for the last couple questions, we are going to factor completely. So that means I have to find every single factor of this function. So what I will do is take the 0 that they gave me, and that is what's going on the inside when I'm, or the outside when I'm using synthetic division. And then I'm gonna see, okay, I've got x cubed, x squared, x, and then a constant, so we're good. I don't have to add any zeros. So this is 1x cubed minus 5x squared, 2x, and 8. This line's gonna tell me where my remainder cuts off. And if this is a 0, if 4 is a 0, there should be no remainder. If you get a remainder, it went wrong. So double check your work. All right, bring down the 1. So 4 times 1 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 4 is negative 4. Negative 4 plus 2 is negative 2. Negative 2 times 4 is negative 8, which leaves me a remainder of 0. Perfect. So I'm going to write this with one less degree. So this is x squared, or 1x squared, minus 1x minus 2. And then I want to factor this further. So I want to find the other zeros. So I'm going to see, okay, what two numbers multiply to make negative 2 and add to make negative 1? So I'm going to have x squared here, so I have x and x. And that means I need to have negative 2 and positive 1. So I have x plus 1 and x minus 2. So that means I have zeros at x equals negative 1, 2, and 4, because they already gave me 4. All right, and then I have one more that I'm gonna do here. This one's a little trickier because it has a 4th degree polynomial, so we're gonna have to do something interesting when we're factoring. So I'm gonna use the 0 on the outside, so I'm using a 1. Looks like it includes all of the powers of x from 4 down to 0, so we're good to go there. So we have 2, 1, negative 11, negative 4, and 12. My remainder should cut off here. Bring down the 2. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. Negative 11 plus 3 is negative 8. Negative 8 times 1 is negative 8. Negative 4 plus negative 8 is negative 12. Negative 12 times 1 is negative 12. 0, no remainder. Excellent. So this leaves me with 2x cubed plus 3x squared minus 8x minus 12. So what I need to do here is actually factor by grouping. So I'm going to find the GCF of this first half and the GCF of the second half. So greatest common factor of the first half is going to be x squared. So I'm taking the x squared out, and I'm left with 2x plus 3. The GCF of the second half is going to be negative 4. And I want to make sure that the parentheses here matches with the parentheses here, so I have to make sure I take out that negative sign. So that leaves me with 2x plus 3. Because negative 4 times 2x is negative 8x, negative 4 times 3 is negative 12. So now that these match, I have x squared minus 4 times 2x plus 3. And this right here, this x squared minus 4 is actually a difference of squares, because I can take the square root of the x squared and square root of 4. So this breaks down into x minus 2 x plus 2, because it's the square root of 4 going here. And then I have to figure out what makes 2x plus 3, what would make that 0? Well, 2x plus 3 equals 0. Take away 3, take away 3. 2x equals negative 3, divide by 2, divide by 2, so x equals negative 3 over 2. So that's one of my zeros. The other zeros are 2 and negative 2. So I have zeros at x equals negative 2, negative 3 over 2, 1, and 2.